1 over 2 or 1 over 3x cubed on the integral 3 to
3 to negative 1. Yeah. I agree. I'm just giving you guys a bit of practice with your integration.
Natural log of x.
But that just gives you this, doesn't it? Which is this. Everybody? Happy? Happy as can be? No, why not?
Or is a negative 1?
I was just using the fundamental theorem.
Oh, you can't do that.
Why not?
Oh, because it's the absolute value. It's the absolute value. Never mind.
Oh, okay.
Yeah.
Linda, you don't want to say anything. I think I'm wrong, 100%. I think I can only apply the fundamental theorem if this particular function in the integrand's position is continuous over the interval from -1 to 3. Did you guys see my point? And so for that reason, I don't think I can use the fundamental theorem in this case. I'm completely out of luck. Are you there?
Split it.
I am going to have to split it. So here's what I'm going to do. I'm going to go ahead and take, by the way, no tricks this time, guys. Because this hyperbola, graphically speaking, has a vertical asymptote at x equals 0, I'm going to play this game. I'm going to think of the integral from -1 to 3 of 1 over x with respect to x as being nothing more than the integral from -1 to
0.
I can't hear you. Okay, I'll do it your way. You're right. I'll put in that extra step. And then from
0 to 3.
You are correct. It's just that I still can't use the fundamental theorem because my function is not continuous over the interval from closed -1 to closed 0. So I'm going to integrate from -1 to how about something really close to 0? And just take the limit as t approaches 0 from the left-hand side of this mess in x plus the integral from something close to 0 up to 3. I'll just make sure I take the limit as t approaches 0, but this time from the right-hand side. I'm still integrating the same darn mess. But I think that's going to give me the limit as t plays who cares what game. But actually, I do care what game. You guys, I take that back. As t approaches 0 from the left-hand side, look at that. My function y equals 1 over x is indeed continuous over the closed interval from -1 to t. And therefore, no tricks. I really can't apply the fundamental theorem calculus. And I will anti-differentiate this beast and evaluate it from here to here. And that's what I'm going to take the limit of. Can I say it one more time over here? I got the limit as t plays this game. 1 over x is antiderivative, which is not that. What is this? Evaluate it from lower bound to upper bound. Let's see what happens. I think that gives me the limit as t plays this game. Let's evaluate. Is that the natural log of t all by itself?
Yes.
Plus the limit as t plays this game of the natural log of 3 minus the natural log of t. I want a yes or no answer. Does this limit exist?
We don't know.
Bless you. I think you do.
Well, if you run a 0 through there, you can't.
What's the natural log of 0?
It doesn't exist.
I think it's horribly undefined.
Yeah.
Do you guys see why? Because when you graph this function right here, y being equal to the natural log of x, this looks like this. So I think as the input gets closer and closer to 0 from the right-hand side, because I'm looking at absolute values, I think the y values are decreasing without bound. So I do not think this is a finite real number. So I just think everything's going to, in English, gosh, how can I say this? I got a new word. I think the limit diverges. Therefore, I think this integral diverges. As a matter of fact, if ever I have an integral from now on, in which I've got a value or a point of discontinuity over this interval, I might refer to this as an improper integral. That's not the only type of improper integral I might have, but it's one type. What the heck does this really mean pictorially speaking? It means a lot. Check this out. X-axis.
Would that be negative?
Yeah.
In this case, it would, because I'm taking the
Oh,
natural
yeah,
log of the
sorry,
absolute
sorry,
values.
yes, that's right.
So everything becomes positive. So you guys, check out what I'm really trying to do. Sort of like I'm trying to find a value for the area between this curve and the x-axis from -1 to +3. I want a yes or no answer. When it comes to that region bounded in green, I said bounded, sorry. When it comes to that shaded green region, is it bounded?
No.
No, it's not. Is this area finite?
No.
No, it's not. You gotta be careful. Just because I've got an unbounded region doesn't mean the actual area is non-finite. It might be finite. Can I give you a quick example? All right, here's a quick one. My last example is that, I promise. And I'll stop talking. And it's a fairly quick one. It's a different type of improper interval. Let's take a peek at this one right here. Do you guys fully understand what the heck I'm looking at visually speaking? Right hand plane.
Is that infinity sign at the top?
It is an infinity symbol, yes. X-axis, Y-axis. My graph looks like this in right hand plane. Here's +1. I think this improper integral is representing the area of this unbounded region. I call it an improper integral for a different reason than before. It's not really because my integram was undefined somewhere over the interval from A to B. I think it's an improper integral because, shoot, one of my bounds of integration has to be infinity. Using a similar logic, I will rewrite this as the limit of t, or excuse me, as t increases that bound of, oh, look at this, you guys, this proper integral, which I can evaluate. And I think I get this. Within the limit, I'll evaluate the integral. But that's going to give you this. But evaluating the limit, that gives me this. Man, nobody jumped. What does it really say?
Area under the curve from 1 to
The area under the curve is +1. If I go to Lowe's and try to buy enough paint to paint this region, can I go to Lowe's? Will they be able to give me the paint? Yeah, it's just 1 gallon. It's just that I'll never be able to finish the job because I can't walk out forever on the x-axis. Do you see my point? So just because I have an unbounded region doesn't mean I've got an infinite area, and this is a perfect example of the areas on. But you guys, I gotta give you better examples than this. I will. If you just give me a tool. Tomorrow, which is what I was going to do today. All right, you guys, let's talk about next week, because next Thursday we're supposed to have our third exam. But you guys remember the first day class, I came in and said, you know, I typed your syllabus up in advance, and I can't give you the exam. I don't want to give you the exam next Thursday. I have to wait till the following Tuesday, because that's the day I'm able to bring somebody in and sit in class and say, I can't be here, I've got some business on campus I have to take care of all day on Tuesday. Now, this sounds bad for you, that the exam is going to be later, therefore cover more material. I promise you, I'll write the exam in such a way that it covers the material only up to next Wednesday. Does that make sense? So it doesn't change what's actually on the exam. I'm not going to penalize you guys because the college has me doing something different that day on Tuesday. Guys, I kind of took a whole day today to figure it out. I hope it was well spent. You know, I think that exam is fundamentally important. It's integration techniques. Maybe the most important exam of the semester.
Well, not until 32, because that all gets thrown out the window. Because none of those functions are actually going to be useful.
Well, I think Math 32 all it's really going to do is take what you're doing now and last semester and pull it in higher dimensional space. I do think with Math 33, man, this exam is everything. You need to know your integration techniques. Yes, sir.
What should we expect on the final? Maybe new material after the third test?
Oh, yes, yeah. As a matter of fact, you and I have 2 weeks of material between the third exam and the final.
Right.
So you should think of the final exam as being divvied up somewhere half and half of new material and
So are we gonna get to Taylor and McLaurin by the next exam?
kind of look.
Yeah.
Sorry, I really have to look.
We got like a chapter and a half before we get to it.
Sorry, I'm so slow, you guys. Tomorrow's Tuesday, Thursday. Oh, definitely not. Definitely not. In fact, what's gonna be on the next exam is gonna cover the remainder of chapter 7 and somewhere into chapter 8. And I'll know,
We go through 10 this semester, or is it just through 9?
yeah, we go all the way through chapter 10.
All the way through chapter 10? Okay.
Which is not bad, it's like, almost like a
Oh,
section.
I looked at 10, it looks like it's just polar graphs, right? Stuff
And
like that,
parametric.
yeah.
Yeah,
That's
such a
nice,
piece.
yeah.
For the final exam, does the college have, does it give us extra time, or is it gonna be just the 2 hours?
I'll do whatever you guys want, as long as we can have everybody do it.
Like, is the class for the final, like, extended any?
The reason why I've avoided the issue is because there's only like a few of us who can't stay late. And I just was, playing the game of waiting till the final exam. It might be the case that those few people aren't here anymore, which means it's not an issue. But if they're still here, I'll do something. I had planned in my head I was gonna do something about the time frame. Because I wouldn't give you more than 2 hours.
Yeah, because I know at Sac State, they usually schedule 2 hours for an hour class. I don't know if they do that here.
We did. You know what happened? The professors got together and voted we don't do it anymore. Because the campus has a minority of faculty that are in math and science, where we need our students to have a full week off and just take a final exam. And other departments apparently were saying, we don't even come to class on finals week, so why bother coming? We don't want to be here. And we just have our students turn in papers, and we just waste the last week. And so, because we're a minority, the college voted, yeah, we'll get rid of finals week. It's just now that we got rid of it, I'm finding that a lot of faculty outside math and science now say for the last week of class, we'll still treat as finals, we're just not going to meet. It's just an endless reduction of order of weeks. It's very annoying. We abandoned it, we shouldn't have, we were all against it in the math and sciences. So we understand the issue, particularly with the math and science students.
Is there a quiz tomorrow and what will it cover?
How about just a quick and easy, simple application of your approximation techniques? Yes. Thanks for reminding me, because I forgot all about it. But a quick and easy short one, so I can use class time. Besides, you had a nice one for take-home, didn't you? Yeah. All right, you guys, can we stop?